This is a video from section 8.2. The given curve is rotated about the y-axis. Find the area of the resulting surface. Let's take a look at example 1. Suppose we have x equals the square root of a squared minus y squared, and y is between 0 and a over 2. So here's the formula we need. Now, in this case, we're rotating the curve about the y-axis. And so S for surface area is going to be the integral of 2 pi x ds this time. And now ds is, again, the square root of 1 plus dy dx to the second dx, or ds is the square root of 1 plus dx dy to the second dy. And it depends on context. Now, in this case, x is a function of y, so we're going to be integrating with respect to y. Now, let's look at dx dy. Dx dy is 1 over 2 square root of a squared minus y squared times negative 2y. Chain rule. The 2's cancel and we get negative y divided by the square root of a squared minus y squared. So 1 plus dx dy to the second is 1 plus y squared over a squared minus y squared. But this is a squared minus y squared divided by a squared minus y squared. It's just another way to write 1 plus y squared over a squared minus y squared. And so, therefore, 1 plus dx dy to the second is, notice how the y squareds cancel, and so we get a squared divided by a squared minus y squared. Just like this. Therefore, we did all the hard work. So S is the integral. Lower limit is 0. Upper limit is a over 2. And it's going to be 2 pi times. Now, x, let's come back, is the square root of a squared minus y squared. So we get the square root of a squared minus y squared. And I'm going to multiply by the square root of a squared over a squared minus y squared. And I'm going to integrate this with respect to y. So this is the integral from 0 to a over 2 of 2 pi times the square root of a squared minus y squared times, now remember, a is non-negative. So this is a over the square root of a squared minus y squared dy. So it simplifies really nicely. Notice how the square root of a squared minus y squareds cancel, and we get the integral from 0 to a over 2 of 2 pi a dy. And so this is 2 pi a times y, evaluated from 0 to a over 2. So I'm going to plug a over 2 in for y, and I'm going to get 2 pi times, 2 pi a, right? And I'm going to multiply by a over 2. And so the answer is pi a squared. And that's how you do the first example. Let's take a look at the second example here. Suppose y is 1/4 x squared minus 1/2 natural log of x, where x is less than or equal to 2 and greater than or equal to 1. Now, dy dx, we're going to need that. So that's 1/2 x minus 1/2x. So dy dx to the second plus 1 is 1 plus 1/2 x minus 1/2x to the second, which is 1 plus. Now I'm going to square out that binomial, so we get 1/4 x squared minus 2 times 1/2 x times 1/2x plus 1/4x squared. So this is 1 plus 1/4 x squared. The 2's cancel, and we get, well, also the x's cancel, so we get minus 1/2 plus 1/4x squared. And so, therefore, 1 plus dy dx to the second is 1/4 x squared. Remember that 1 minus 1/2 is plus 1/2 plus 1/4x squared. That's a perfect square by design. That's going to be 1/2 x plus 1/2x to the second power, it looks like. Okay? Now, remember that my formula is S for surface area is the integral. Now, remember we're revolving the curve about the y-axis, so it's going to be 2 pi x ds. But this time, if you look back at the question over here, y is a function of x. Y is a function of x. So this is going to be the integral from 1 to 2 of 2 pi. I'm integrating with respect to x this time, so I'm going to leave the x alone, and I'm going to multiply by the square root of 1/2 x plus 1/2x raised to the second dx. So this is the integral from 1 to 2 of 2 pi x times 1/2 x plus 1/2x dx. So when you take the square root of something squared, you get what's inside those parentheses, which in this case is 1/2 x plus 1/2x. Distribute the x in. So this is 2 pi times the integral from 1 to 2. I could have distributed the 2, but it's okay. So we get 1/2 x squared plus 1/2, looks like, dx. So this is 2 pi times. Now integrate both terms. We're going to get 1/6 x cubed plus 1/2 x evaluated from 1 up to 2. So this is 2 pi times. Plug the 2 in, we get 8/6 plus 1, right? 1/2 of 2 is 1. plug the 1 in, we get 1 over 6 plus a half. Now, the common denominator is 6, so I'm going to get 2 pi times 8 over 6 plus 6 over 6 minus 1 over 6 minus 3 over 6. So 8 plus 6 is 14. 14 minus 1 is 13. 13 minus 3 is 10. So it looks like we get 10 over 6. So this is 2 pi times 10 divided by 6. But 2 goes into 6 3 times. And so the answer here is 10 pi over 3. And that will conclude this video for section 8.2. We found surface area by rotating the curve about the y-axis this time. So, thank you.